I'm using the copper foil grain boundary demo dataset for this section. This was collected on a thin copper specimen. A grain boundary is the interface of grains or crystallites in a sample. The first thing to point out is that this is a 4-dimensional dataset. As you can see, the size of the object is 45 by 45 by 512 by 512 pixels. The first 2 dimensions are real space or scan dimensions. The second 2 are the diffraction dimensions. Remember, with STEMx, we collect a diffraction image for each STEM probe or pixel position, so a 4D data cube. We can't visualize all 4 dimensions of our data on a 2D screen at the same time. Fortunately, Digital Micrograph has some nice inbuilt tools specifically for spectrum image visualization. Go to the spectrum image, right-click and select the SI Picker tool. A labeled ROI will appear on the image, and a new image window is opened in the software showing the diffraction pattern from this pixel. If I grab the picker tool and move it from one grain to the other, you see that the diffraction pattern changes, meaning that the 2 grains have different crystalline orientations, hence why there's a grain boundary here. Right now, the diffraction image displayed is only from the single pixel selected by the picker tool. I can resize the picker ROI by clicking one of the corners, holding the mouse button and dragging to change the region selected. By doing this, I'm summing data from multiple pixels instead of a single pixel in the data cube. Look at how the pixel intensity in the diffraction pattern changed from a few thousand to a few 100,000 counts as I changed the picker region to include multiple pixels. We aren't limited to one SI picker per dataset. I can right-click on the image, select the picker tool and extract another diffraction pattern. For this data, I can use this feature to extract and compare diffraction images from different grains side by side in the software. A really useful shortcut to access the picker tool is to just hold the control key and left-click on a pixel, like I'm doing here. You could do this multiple times. Extracted diffraction data is always linked to a picker ROI, as long as the ROI remains on the SI data cube. Closing an extracted diffraction pattern will automatically delete the associated picker tool. To break the linkage but leave the diffraction pattern open, just highlight and delete the picker ROI corresponding to the diffraction data that you want to separate. If a 4D data cube is saved with a picker tool, the extracted diffraction pattern will be kept and displayed next time the 4D data cube is opened in DM. Now let's cover some more advanced data extraction tricks. It's possible to sum diffraction patterns from multiple ROIs, as well as ROIs with other or irregular selection of pixels, not just a rectangular selection as we did with the picker tool. Right-click on the 4D data cube and select one of the 2D ROI tools, either the rectangle, loop, or oval. Next, draw an ROI on the image. You can add as many ROIs as you need, and they can be different shapes. Just remember that you have to hold the Shift key as you draw a second, third, fourth, and so on ROI. If you don't hold Shift, the software will redraw your first ROI. For my second ROI, I'm going to use an oval. I just hold the Shift key and draw on my 4D data cube again, now the oval ROI tool is selected. After drawing the oval on the SI cube, I let go of the Shift key on the keyboard, which allows me to move the ROIs around and change their shape and size as needed. I'm happy with the ROIs, so now I want to extract some data. To do this, I go to the SI menu and select the Sum in Selected Regions menu item. Digital Micrograph calculates the sum of all the diffraction images contained within the ROI boundaries, and then displays a diffraction pattern as you see here. Using the picker tool to extract diffraction patterns from a single pixel or the sum of diffraction patterns from multiple pixels using the ROI and sum tools is equivalent to collecting a diffraction pattern from a selected area of the sample in the microscope with a selected area aperture. The diffraction patterns reproduced here are virtual, selected area electron diffraction patterns, or SAED patterns for short. The picker tool or ROI tools are acting as virtual apertures with which we generate the diffraction images.